Hey, what's going on, everybody? Welcome back to Civil Engineering Academy. My name's Cody. Let's go ahead and get started. All right, so today we have a soil mechanics types of problem, and we're going to be talking about properties. So here's what the question says. A particular soil sample has the following attributes. We're given the LL, liquid limit. We need to know that. It's 32. PI, plasticity index, that's 44. And greater than 50% of soil passes the number 200 sieve. So we need to know that. Which of the following most closely resembles the soil description of the soil sample? We're given four options there: well-graded gravel, well-graded sand, lean clay, fat clay. So what we need to do is ultimately figure out which method, which classification system are we going to be using. Well, the USCS method actually uses a group symbol and a group name, or we could have thrown in a group symbol instead of a group name here, but point being, the AASHTO method actually uses an A dash with a number as the classification. That's going to be how they classify a soil type. And so right away, we're looking at our options that are available to us. That's going to be the USCS method. So that's step number one, is identify which ones we're dealing with. And if we're looking for some reading material in the FE manuals, at the time of this video, it's going to be version 10.2. We're going to be in the civil engineering section, so CIVILENG. I'm going to write that for short. And then we're going to be in page 267, so page 267. And then in the PE manuals, we're going to be in version 1.1, and this is going to be in section 3.7.2, and we're going to be in page 116. So that's where we're looking. That's where you can find the classification charts, the USCS classification charts. I'm not really sure if I can pull it over, if I can include a snip into this problem, so we're going to play it safe due to copyright issues, and I'm just going to have you guys follow along with me. I'm going to try and write down the steps the best I can, but it would really be good for you to pull up the manual on maybe half your screen and have this video going on the other half of the screen, and just follow along. See if it makes sense to you, and we'll work through this problem together. Now, whenever we look at the USCS classification chart, if you're taking the FE, you'll notice that the coarse grain soil and fine grain soil classification, or difference really, is on the left side of your chart, whereas in the PE, it's up top. It's on the top of your chart, but the rules still apply. I mean, it's just a different way to look at it here, but let's see. So the first classification here is 50% or more, more than 50% retained in the number 200 sieve. That doesn't really apply to us because we have greater than 50% of the soil passing the number 200. So don't get that mixed up. Basically, if it's if it's retained, the size is greater than that sieve. So we're talking a number 200 sieve, 0.075 millimeters. Anything greater in size than a 0.05 millimeters is going to stay above it. It's going to be retained in that sieve. Whereas if it passes, it's smaller than 0.075 millimeters. So that we're going to be dealing with some fine stuff. And so that's the next classification there, is fine grain soil, silts and clays. That's what we're going to be dealing with. And so you can ignore the other half of the USCS classification chart, right? So the coarse grain soils doesn't apply to us. We're dealing with some fine stuff, silts and clays in particular. Now the next requirement is the liquid limit. Is it less than or greater than 50? Well, in our case, it's 32, less than 50, and so that means that we're gonna further filter, I guess, our chart, I guess, to only include half of the fine grained soils classification. So now we're talking silts and clays with the liquid limit less than 50. So that's CL, ML, or OL. So low plasticity stuff is what we're dealing with. And so now the further classification, inorganic, organic, we don't know that. It's not given to us in the problem. And then we're kind of given like some weird stuff. So the PI needs to be greater than 7 and plots on or above the A line. Or, so that will give us the CL, the lean clay, or PI needs to be less than 4 or plots below the A line. That's the ML, the silt, low plasticity silt. That's what that L means, by the way. But that's not even an answer in our problem, so you can go ahead and ignore that. But I'm going to go ahead and show you or walk you through how to solve that on the chart. So then the next qualification is if it's an organic, low plasticity clay or silt, right? Well, that's also, again, not an option, so you can already get your answer right here. But we're going to go ahead and practice on the chart anyways, just understanding how it works, just in case. And then, yeah, so I'm going to go ahead and write down the steps, basically how we got to this point, and then I'm going to go and start on the chart. Again, I can't really include the chart in this video, but I'm going to explain how we get to the answer that we do. All right, and so now we're caught up, greater than 50% passing the number 200, therefore it's fine grained. And then we have a liquid limit less than 50. And then we're talking inorganic, organic, what kind of inorganic, if we are inorganic. And let's go ahead and take a look at the qualifications. The PI needs to be greater than 7. That qualifies us. And it plots on or above the A line. And so that means we need to scroll down to our plasticity chart for the USCS method. And you'll notice we have liquid limit on the x-axis, plasticity index on the y. Liquid limit's 32, so you can kind of follow along with your cursor here. Our plasticity index was 44, so we are well above that A line. So that means we are a CL, which is a lean clay, so a low plasticity clay. And so that answer right there puts us at C. So I hope this video helps, and we'll catch you next time.